Hi, it's Mrs. Basaga, and I'm going to go over some review of RobotC or some intro to RobotC for those of you who have either never programmed a VEX robot before, or those of you who took POE a couple of years ago and maybe you just can't remember exactly where everything is. So the first thing I'm going to do is I'm going to go to Window, Menu Level, and I need to make sure that Expert is selected. And that doesn't necessarily mean that I'm like an expert RobotC user. What it means is that I have access to some different menus that I otherwise would not have. After I have done that, I'm going to go to Robot Platform Type, and I need to make sure that VEX 2.0 Cortex is selected. If it is not, I need to select it, and I can also find that underneath Robot Platform Type VEX Robotics 2.0 Cortex. I also need to make sure that natural language is turned on for my robot. So I'm going to go to Robot, Platform Type, and make sure that natural language PLTW is selected. I do have to select the Cortex first in order to get this menu. But what it does is it gives me access to this menu natural language over here on the left, which gives me some really nice things as far as being able to quickly find information about how things are worded. For example, under the Movement tab, I have information about the servo port to start and stop the motor. And one of the nice things is that when I hover over something, for example, if I hover over Start Motor, it gives me information about what that motor's range is, where it can be put on my Cortex, that kind of stuff. Okay, I'm going to open up a new file by going to File, Open Sample Program. And I want to look in my VEX2 folder for PLTW and choose the PLTW template. And then I'm going to want to save this as a different type of file. So something that I've recently done or whatever my new activity is. So I have an example of a test of a RobotC program saved in here. So let's talk a little bit about the parts of the RobotC program. At the top up here that I've just highlighted, and let's remove that, is my pragma statements. My pragma statements contain all of my configuration. To get to that configuration, I am going to go to Robot, Motors and Sensors Setup. And you can see here my settings. So for example, the first thing you want to do is go to Motors, and you'll want to program in your motors. So see how I've got left motor here and right motor. And on my type, I can drop down that menu and select whatever my motors are. After you get through motor port 1, you do get the option for your servo, okay, or the flashlight. One of the things I wanted to point out is that whenever we're doing any type of programming, the capitalization or lowercase becomes important for my command. So for example, in left motor, my M is capitalized, just like it will be if you follow along with the activity instructions. That would be very different than left motor with a lowercase m. The programming, the compiler doesn't know how to deal with that if I don't have that capital M and it's expecting that capital M. So that was found under Robot Motors and Sensor Setup Motors tab. I also have my analog sensors. So I have the light sensor. If I drop this one down, you can see I'd have potentiometer, my line follower, anything else that we might have that we would want to plug in. And on my digital sensors, I have the red LED for this example, but I would also have a touch sensor, a quadrature encoder, and a digital in and out will become important when we do the final project. And then my sonar is listed there as well. Okay, go ahead and cancel that. So all that information after I put it into my program shows up in my pragma statements. Down here in the green section, I have the information that I want to include about my program. So my title, just test. My team members are my dogs. Today's date is period 5. Okay. My task description. That is going to tell me in a sentence or two what my program is going to do. Now, this is a simple program. So it's going to turn on the motor, wait 5 seconds, turn off the motor, and then turn on the LED. Okay. And I can use plain language for this. And it's okay if I'm missing some parts, because I'm going to then think about it stepwise when I get to my pseudocode, which is right here. My pseudocode is that step-to-step programming that we thought about when we did the flowchart activity a few days ago. So this is the example of the beginning of mine, where my task description says to turn on the motor, so I'm going to have to include every little detail. Turn on left motor at full speed going forward. So my motor can go from 127 positive value, which is forward, through minus 127, which is full speed in the backwards direction. It would then wait 5 seconds, and then I would want to include something like turn off left motor, and then turn on LED. Okay, so that would be my pseudocode. Here underneath the task main, so task main is where my compiler starts to actually read my program, and anything that is from this brace to this bottom curly brace is included in my programming. So to do this, I'm going to look at my pseudocode step by step. So that's my first one, turn on the left motor at full speed forward, and I'm going to program that right here using my natural language. So let me delete that so you can see how this works. So to put in my program, I go to natural language. I'm going to go to movement, because that's where my motor is. And I'm going to click and drag on start motor. Okay, now I've got some options. So where it says motor port, I'm going to change it to be left motor. And then my speed is going to be 127. And then I want to include, with 2 forward slashes, my comments. So this would match my pseudocode then. Turn on left motor at full speed forward. Okay, so then my next step would be to wait. So I go to wait, and I do the same thing. I go to drag and drop my wait time 5. So I picked the wait time seconds, not the wait in milliseconds. And then I can go over here and wait 5 seconds. Okay. Turn off my left motor, stop motor port. Once again, I need to make sure I'm capitalizing as needed. Turn off left motor. And then finally, underneath special is to turn on the LED. So the name for that will be red LED. Okay, there's my other curly brace. So pretty straightforward. What I need to do then is save, once again, saving my program as whatever my new activities file name is. And then to run it, I need to hook my Cortex up to my computer. And to do that, I hook one end of the USB up to the Cortex. I put a battery on the Cortex and I turn it on. And then my other end of the USB cord goes into my computer. I will go to Robot, compile and download program, and right now it's going to give me an error message because I'm not hooked up to a VEX Cortex. But down here at the bottom where it says compiler errors, I would see any of my compiler errors. So if I accidentally deleted one of these, or I didn't put the right cases or something in here, forgot to make a change, maybe I forgot to change red LED to be red LED, that would show up down here. And then I would also have at the bottom these tabs that would let me see the digital and analog ins and outs. And that will become important when you do things throughout this activity. For example, testing the potentiometer or deciding what the value is with the light sensor. Okay, so we will work on this a little bit more in class, and I'll go through some examples, but make sure that you go back and rewind to any part of this video that you need, and hopefully this video helps you get set up on the first part of your CIM-POE test bed.